Hello, everyone, and welcome to our second edition of GMAT Quant from the ground up. Our first edition was 2 weeks ago. I actually hosted that one as well. It covered the core manipulations that you can do with various types of equations, what I consider the core algebra components, things with exponent manipulations, standard linear equations, some absolute value ideas. And today we're going to be tackling fractions, percents, and ratios. And we begin by just building the foundations. So, again, as we're going through this, feel free to type in the chat and just let me know which answers you're selecting, if you have any questions, and also if you have any areas that you know you struggle with most. But in the meantime, everyone take a moment, try this problem. Type in the chat when you have your answer. So, the beginning part of today's discussion is just making sure that we lay some foundational ideas. And the foundational idea for fraction mechanics is maintaining balance. You can do anything that you want to do so long as you are doing it, changing the top and the bottom in the same way. And we're speaking in terms of, like, more specifically, I shouldn't say anything. What's really happening is you have to multiply by something that is functionally equivalent to 1. Multiplying by something that is functionally equivalent to 1, you are not changing the value, you are merely changing the format. And so we start with 3.10 over 0.2. And I want to multiply this by anything that is functionally equivalent to 1. And I can make it anything of my choice. I can make it 7 over 7. I could make it pi over pi, even though GMAT no longer tests geometry. Any of these would be valid, but that's not the thing that I want to multiply it by. What would I want to multiply this by to change the format but not the value? Anyone have any thoughts? 10 over 10. Because one of the personal rules that I have is I will not let the test, and I teach GMAT, GRE, and executive assessments, and the same is true in any test, and very true for the GMAT. GMAT is notorious for this. Do not let them make you work in mixed formats. Do not let them mix decimal notation and fraction notation in the same problem. That just naturally makes things much more difficult. Multiply by 10 to get a 31, divided by 2, and hello to you as well. When I do 31 divided by 2, we will get just a tiny bit over 15, 15.5. So we have foundational ideas with fractions. You are allowed to change the format. In fact, many times you are encouraged to change the format of the fraction. You want to do that by multiplying by something that is equivalent to 1. All right. Let's take a look at this one. Same idea. Everyone take a moment. Type in answers when you have them. All right, getting some answers in. The core mechanic for a percentage calculation is to recognize that every percentage is at its heart something expressed as out of 100 pieces. So there is some percentage, something expressed as out of 100 pieces, which is equivalent to this decimal. Well, we want to solve that percentage, so we multiply both sides by 100. And we're seeing here, not called out explicitly in the problems today, but inherent in our manipulations, is that decimals and fractions and ratios and powers of 10 are oftentimes very interchangeable here. Multiplied by 100 is the same thing as trading off two decimal places, and I will get 32.5. Perfect. All right. Again, just working on a few core foundations before we get to some common traps and then to some more interesting problems. All right. Once again, same game. Let me know your answer when you have it for this problem. All right, getting some answers in again. Now, what I'm about to do on the screen may feel like overkill, may feel like it's more than is needed for this problem. And I'd be okay with that position. But I want to begin showing frameworks that will be very useful for us in a wide variety of problems. And one framework that is very considered, oh, no, I wanted to have the pen tool. PowerPoint always wants to do that to me. All right. Very, very common is to have this idea of a total broken into pieces. And in this case, Sally has some amount of her gross pay. There is some piece that goes to taxes, and then there is some piece that remains. And we can start by just filling in this idea that I don't know what her pay is, so I'll give it a variable. I know that once we take off taxes, she keeps 4/5 of that, which means that the other portion must have been 1/5. And we are told that the monthly taxes are $1,400. Multiply both sides by 5 to remove our fractions. So I'll have a 14 times a 100. Multiply that by 5. 5 times 14 will be a 50 plus a 20. So that's a 70 with another 2 zeros on it. D, 7,000. So here we have 3 core foundational mechanics for these content areas. We have this fundamental idea that fractions manipulations are about maintaining the value even if we change the format. So you're going to be multiplying by something that is functionally 1. Percentages are always something expressed out of 100 pieces. And then there is going to be this idea with a lot of fraction, percent, and ratio problems where you have this total broken into component pieces. And so those are some of our most common foundational ideas. Looking at the speed with which the correct answers came in on the last 2 problems, I suspect that everyone is comfortable, but I just want to pause for a moment because I never want to assume. Is everyone comfortable with these 3 ideas? Just type in yes in the chat and we'll move into what are some traps. Like just a quick confirmation, yes, you are comfortable with everything that we've done with the last 3 problems. While I pour myself another glass of water. Excellent. Getting some yeses in the chat. Beautiful. All right. Common traps. I say traps plural as though there's more than one. They will present it in more than one way, but fundamentally, there's really just one trap for all these topic areas, and that is they are not numbers. Now, I say that that's always true for a percentage. Every percentage, you need to ask percent of what? That's mostly true for fractions. It's very true for fractions in story-based problems, like in that one about Sally and her pay and her taxes. She keeps 4/5 of her pay. 4/5 of what? Make sure you have that on your paper. Ratios, I say it's not so much trap, it's more the key to unlocking the solution. The idea about ratios is that you have to put something on your paper as a mechanic that is always illustrating front of mind, that when I say that something has a 1-to-2 ratio, it doesn't literally mean that it's one item to two items. Let's take a look at a few problems. This one's just a little made-up example. Everyone take a moment. What is the profit on this item? $40 or $50 item? $40 or $50? Type in your answer when you have it. Oh my God. Oh yes, I swear I'm a professional. I do this for a living. I was on mute that entire time. Can everyone hear me now? Let me know that you can hear me now, please. I should be off mute, but I just want a confirmation. Okay. So, I mean, you see what I put on the screen. So perhaps the audio here is, just a little discussion for this. So we walk right into a trap here because we say you've got a cost, a markup, a sale price. And we know the cost is $200. We know the markup, it's a 20% markup, and we go, great, 20% of 200. That is the same of 1/5 of 200, which is 40. So you have a markup of $40 for a final sale price of 240. If your sale price is 240, your cost was 200. That means you have a profit of 40. And we have this issue where we have made a mistake somewhere. And I have a request in the chat for a way forward to ace the GMAT. That is a very, very heavy question. I will tell you that it is not something that I can give you a guaranteed answer in one sentence, but I can tell you that the number one thing about the GMAT is understand what the scoring algorithm means about how you take the test. Most people are aware that the GMAT is in some ways a computer adaptive test. And they take from this a misconception that that means the most difficult questions are most valuable. And it's actually the other way around. The biggest thing to acing the GMAT is to make sure that you are completely confident and correct and quick on the easier questions. High scores on the GMAT are more about making sure that we do not make losses on the easier problems. In the meantime, does anyone notice where the mistake happened in this operation? Even if you're not sure how to describe it, if you notice it, you could say yes. If you don't notice it, if you're sitting here going, Chris, I'm so confused. The math here is so self-evident. 20% of 200 is $40. Why is it? There we go. Thank you, Shreya. We applied our percentage to the wrong base value. Every percentage is always percent of what? And this 20%, it's not 20% of the cost. So again, we have some cost, we have some markup, and we have some sale price. And I know the cost is 200. I don't know the sale price, so I'm just going to give it a variable S. And I know the markup is 20% or 1/5 of the sale price. Now we can build an equation. Cost plus the markup equals the sale price. 200 plus 1/5 of S equals S. Subtract 1/5 of S away from both sides. I'll have 4/5 of S. Solve for S. Multiply by 5/4 to both sides of this equation. 4 goes into 250 times. 5 times 50 is 250. And so my profit here will actually be $50. Every percent, we must make sure we have identified percentage of what. Their happiest trap on percent questions on this test is phrasing the problem in such a way where it's very easy to apply the percentage to a different base number than the one actually required by the problem. And again, I noticed that we have in the chat the link to the full schedule of this series. So I'll just do one more call out here. This is part 2 of a 7-part series. Part 1 is already available. It is me going through what I consider the most core algebra fundamentals. And we could move forward here today with fraction percent ratios. And the next one's going to be story problems. Thank you. So a way forward how to ace it. And I was sitting there going, I was having trouble remembering exactly what the title was. Yeah. How non-math people can win GMAT quantitative. All right. Everyone take a few moments. If you are not too familiar with this question type yet, be very, very aware of what the answer choices say about how the statements work. But otherwise, take a few moments. Again, as always, answers in the chat when you have them. Okay. This is the first time today when I've got a lot of people taking a full 2 minutes to respond to the question. Even in the earlier question where most people were trapped, we still had responses coming in much more quickly. I would like to just begin by asking, was there something about this problem that made it feel more time consuming to you? And if so, what was that? And I'm getting a mixture of choices A and D. So it appears that everyone agrees that statement 1 alone does answer the question. But there seems to be some debate on whether statement 2 also answers the question. And I'm just going to keep an eye on the chat. And if anyone has anything they want to say about whether this problem felt longer to them, we'll get to that in a second. All right. So first up, take a moment. We want to understand what's happening here. We're given a prompt about these 3 people. We want to focus on Bob, and we are given a story framework, even if it's a very short story. So I'll almost certainly want some organization. I see that there's a ratio component, again, coming through with the theme that what we're going to see with traps, the idea of this 1 to 2 to 4 are not real numbers. It's not literally 1 hour, 2 hours, and 4 hours. And so we're planning this out. Joe, Bob, Dan. And I know that it's 1 times something, 2 times something, 4 times something. Thank you, Jimmy. Yes. If we're not familiar with this question type, it does take more time to become comfortable with the logic of the answer choices, especially. The good news for that is that a little bit of exposure and practice with this question type, the answer choices become very automatic for you. And we also see that at some point to address statement 2, we will want to be ready to talk about the total. So this will be a total of some 7x hours. Again, seeing here the fundamental idea behind this, these ratios are not numbers. What do we want? We want Bob, which means we want 2x. which means we want x. Anything that can get me x will be enough to answer this question. I look at statement 1. Together, their total is 49. So I can go ahead and rewrite that as 7x equals 49. I can solve for x. This will be sufficient on its own. I look at statement 2. Dan worked 21 more hours more than Joe. Now, for our purposes, the reason we set up this chart is because Dan is no longer Dan. Dan is now 4x. And Dan worked 21 more hours than Joe. Joe is not Joe. Joe is a 1x. Combine my x terms, 3x equals 21. And I can see that I can solve for x there. And so that will also be sufficient. And so we see here that since statement 1 and statement 2 each were sufficient on their own, we would be selecting choice D. Questions, comments, or concerns? We did see a significant split on the answer choices here. While I'm waiting to see if there are any comments or concerns in the chat, I'll go back to where I had the work on the screen. All right, so what we're seeing now, just 3 examples where just the recurring theme for this, they are not numbers. We must ask a percentage of what? That will also be true for most fraction statements. And then for ratios, we will always want a multiplier on our ratio. We always want to be able to say that 1 to 2 to 4, the 1x, 2x, 4x. All right. Now let's get into some more problems that are going to be more aligned with the kind of a length that we would expect to see on the actual test. And let's start with the graph question. The idea behind this question type, you have your graph. Oh, let me get the pointer tool here. You have your graph. Take a moment, make sure that you assess what the graph has, make sure you identify what the key is, use these pieces of information to make sure you are interpreting the graph correctly. And then what you have here will be statements that have drop-down menus. It's always 2 drop-down menus for this question type. And on the actual test, when you click this drop-down menu, you would see this table of options. And when you click to this drop-down menu, you would see this table of options. Take some time. Let me know in the chat when you have answers. and it just occurred to me that I might owe everyone an apology. I jumped into this without remembering to remind you that when you see this question type, it will occur in the data insight section where you do have a calculator. So if a calculator would make your final steps on this problem easier, go ahead and grab it. In the meantime, I mentioned a moment ago this understand, plan, solve mentality. We always want to be framing things in this context. We want to make sure that we know what the problem is dealing with. We want to know what we need. We want to build a plan. We want to decide, do I need organization? Can I go straight to equations? Will I need algebra? Could I just number test the problem? Those kinds of ideas. And then when we solve, we just want to be very aware that we are putting all of our components in the correct place, taking a moment to double check our assignments and our work, and making sure we have the correct final steps for our problem. So, understand. My theme for everything data insights is make sure that I understand the prompt first. And for graphs and tables, that is very much make sure that I look for any trends and outliers. So before I actually do anything here, I want to make sure that I first notice, well, I've got two different line graphs. Let's be aware I have 2009 is the tighter dots, 2000 is the dots with more space. So 2009 is the one that coasts up here, and then we see some dips kind of things here. 2000 stays a little bit lower, and then dips and moves there. And so in terms of a trend, one thing that I might want to be aware of is that it appears that the average age in this country skewed up from 2000 to 2009, because I've got a significant amount of space here where 2009, we are seeing more people at older age demographics than we saw in 2000. So, for example, when I look at this second question, the population of 55 to 59-year-olds increased by approximately some percentage. I should not be surprised by that question. I should be thinking, yeah, that's expected. When I looked at the graph, it seems that there is a shift to older demographics in this country across this 10-year period. All right. The other thing that we want to do here is recognize that when we have this understand, plan, solve idea, one of our things with percentages is we need to be very, very, very deliberate on whether it is percent of a number versus percent change. Let me get a different highlighter color there. We'll go with a light blue. So for our percent of, we can write it as just, we have our original value here, our 35 to 39-year-olds. This is what I'm going to solve problem 1 here. My 35 to 39 looks to be around 225 in 2000. Whereas my 60 to 64-year-olds, if I'm looking at 2000 for 60 to 64, that appears to be right around 110. And so this idea of percent of is going to be a much more direct, your new number divided by your base value. So in this case, my new number divided by my base, that should be 110, excuse me. And that will give me a decimal expression, which once I have the decimal expression, we can go back to our very first idea of foundations, where we saw this. Converting a decimal expression into a percentage involves recognition that I have to rephrase every decimal as, this is out of 100 pieces, and that was my percentage. Now, at this point, we could do the calculation. Or we could recognize that the number is significantly larger. So it cannot be 40% or 50% of that original number. It went up, not down. And this is almost double. Almost double that number, just a little bit more than double. And so we would go with 210 there. You will find that it's actually very, very common on this question type to be able to use the drop-down options to make some quick eliminations based on reasonableness estimates. When I'm looking at problem 2, a percent change, this percent change is the difference divided by the base number. There are various ways to describe this, but this is one that I want you to have. If it's percent of and you know the numbers, nu divided by base, that's your decimal expression, turn that into a percentage. If it's percent change and you have the actual numbers, difference divided by base. So my 2,000 55 to 59-year-olds, let's go back here. The 2000 number looks to be right at 140. The 09 number from a 55 to 59 looks to be right at around 190. And so my difference here would be a difference of 50. My base would be 140. That is going to be just a little bit more than a third. So we would go with 40% on that one. Now I did have multiple people going for 60 for the second drop down. I'm curious whether there was something that was leading us to 60. Was there some way that we got trapped here? I'll continue to hold here for a moment. Anyway, the ultimate point from this problem is this idea that I want to be able to quickly acknowledge percent of versus percent change, and when I have the numbers, put them into a efficient calculation quickly and correctly. And there is some algebra justification that underlies these two definitions, nu divided by base and difference divided by base. And if you go to various different books and sources for this, you may find different ways to describe it, but it is all the same idea. I just want to be able to get to that efficiently. All right. Let's try a new one. Same idea. Take a few moments. Let me know in the chat when you have an answer. Are we delighted with this problem? I do have one answer in. If this one was giving you trouble, I'd like to get some reactions in the chat as to what felt troublesome about this problem. This is something that we do see on the GMAT fairly often. They like to give you comparison frameworks and hope that you feel lost in the comparison. And while there are different ways to go about these problems, they do have one recurring theme. And that recurring theme is I need a common framework for comparison across all the choices. Now, for a fraction, that means either I need the denominator to be the same or the numerator can be the same. If the denominator of every fraction is the same, then the largest numerator means you have the largest value. If the numerator of every fraction was the same, then the smallest denominator would mean the largest value. For myself, I would prefer to say, let's build a common denominator. That way, at the end of this, I'm now just looking for the largest thing. So my common denominator, I see that I need to include a 9 factorial. That is the largest factorial term that exists in all of them. And I also see that I need to include a 5. So what I need to do is I need to make sure that I have a common denominator of 5 and 9 factorial for every single one, which means that we're going back to our core mechanic of multiplying by something that is functionally 1. And so in order to get a 9 factorial and a 5, I will need a 5 and I will need a 9. That 9 times 8 factorial will be a 9 factorial, which means I need a 5 and a 9 up here. So now notice that what I'm going to do next is not mathematics. It's not algebra. It's just a recognition that once I've made my denominator the same, I am now just comparing numerators. The 3 times the 5 times the 9 is the only thing I'm going to care about. Here, well, this one's already done. It has the 5, it has the 9 factorial. So 6 times 4 times 3 times 2. I personally would go ahead and break all these factorials into their pieces because I will find it easier to compare piece versus piece than other options. This one, I don't have my 5 yet. So multiply by something that is functionally 1. And so now I will have my 5 and 9 factorial there. And I'll be left with a 5 times 4 times 3 times 2 times 1 technically, but the times 1 isn't going to do anything. Here, that 7 factorial isn't yet a 9 factorial until I get an 8 and a 9 involved. So I'll need an 8 and a 9 in both numerator and denominator there. So I'll have a 3 times an 8 times a 9. Here, that 8 factorial is just missing a 9. So here I'll just need a 14 times a 9, which I'll again break down into a 7 times a 2 times a 9. And now I am comparing. And now as I look at this, just looking at my comparisons, I can see, I'll just tell you what I notice as I'm noticing it here. This 3 times 8 times 9 versus a 3 times 5 times 9. The 3's are the same, the 9's are the same, the 5 is smaller. So choice A, gone. I look at B versus C. 6 times 4 times 3 times 2 versus 5 times 4 times 3 times 2. That 5 is smaller. C is gone. And so now I could look at D versus E and say, if I need to build a comparison here, this is a 24 times a 9. This is a 14 times a 9. Again, just trying to coordinate the pieces here. E is smaller. And then B versus D. I see that my 3's are the same. So here I'm really just looking at 8 times a 9 when I'm comparing B versus D, and then 12 times a 2. And 8 times 9 is going to be a lot larger than, 24 times 2 rather. But 8 times 9 will still be larger. I'm going to be left with it. Recurring theme on a problem like this, we need to have some common comparison basis before we can start building our comparisons. And after that, this comes back to your fraction mechanics, just a very complicated example of the fraction mechanics where we have a I need to change the format without changing the value. All right, before we look at one last problem, I want to point out that one of your core principles for how you want to be studying is making sure that you're reviewing every single problem. Solution explanations are a tool of last resort. Find out what the correct answer is, but try not to use an explanation unless you absolutely have to. Explanations written by someone else tell you how someone else would solve the problem. That may not be the best path for you. Try to find your path to the correct answer and then use the explanation as a check to see, I found my path. Do I like my path better or do I like this other path better? Make sure that we are looking at what takeaways we want from this. Every single problem has some type of takeaway. For example, in the previous one, our takeaway would need to be, if I need to compare things, I need a common element as a foundation for my comparison. And then please make sure that you review ones you got correct. Be honest with yourself about whether you maybe got a little bit lucky, in which case you need to be more firm with how you get to the solution and more careful with that one. And then always ask, even if I got it right, could I get it right faster? Keep in mind as well that we have a lot of free resources available on the webpage here, and you can always get started with that. You can also always sign up as a trial student for one of our classes. So you can join the first class for free at any class and use that there. And then additionally, we are right now running some pretty significant discounts. Go to this website, check out and see which discounts are available for you. And that might take some of the sting out of the price of the courses there. All right. Does anyone have any comments or concerns before we try one last problem today? I think that we should do this problem next. Everyone take a few moments. Try this problem as the last one of the day. All right, getting some answers in. The reason I selected this problem was because I wanted one more callback to the concept that I built a trap around earlier. The concept of we must be very, very aware of percent of what. In this particular problem, I don't I did not intend it as a trap. I intended it as a way to get to the answer much more easily than with a strict algebra manipulation. But before we get to that, just take a moment, understand what we have here. We have our story. We need to track gold versus silver versus total. There's a change in the element here, so I'm going to make sure that I have a plan or an organization to reflect the amount of each and how it changes. And then as I solve, let's just be very, very aware that I'm going to be very careful with my mechanics, and that the answer choices suggest that maybe I can sidestep the algebra, because the answer choices, and in fact, every single number in this problem is a fairly workable number. So gold, silver, total. I was chemical engineering undergrad, and so I know the chemical symbols for gold and silver still. And so I debated whether I'd be completely nerdy about that and use the chemical symbols, but I decided, no, that's really not necessary. And so we have some initial, some change, and some final amount. And I know that we start off with a total of 10 grams, and it's 3 grams of silver. And that means there must be 7 grams of gold initially. And I know I'm going to be adding some gold. So I'm going to be adding some gold here. I just don't know how much. I know I'm not going to be adding any silver. That's not going to change. So that means that my total weight is only going to change by whatever the gold did. And so the only thing that I have right now that's known is that silver is going to stay the same. And yes, we can build an algebraic expression here and work through all this, or we can say 10% of something. 10% of that final total must be 3. So 10% of what is 3? Well, that's 30. 10% of 30 is 3. So that means how much must we have added? We must have added 20. There is an algebra way to do it. You'd set it up here as like your total is going to be that 10 plus x. But I wanted to come back to this problem for the express purpose of showing again that if we keep the percent of what firmly at the forefront of our approach for any percent-based problem, and almost always true for fraction problems as well, especially if there's a fraction in the story, then we will be much more successful with these, and usually much more quickly. All right. My friends, that is almost our time for today. I want to say thank you for being so active in the chat and participating so readily. I hope that you found this discussion helpful. I hope that moving forward, I've given you a few frameworks that you can use to really rip through these percent, fraction, and ratio style problems very efficiently and very confidently. And as I mentioned earlier, this is part 2 of a 7-part series. In another couple of weeks, my colleague Ryan is going to be going through some more story-based problems here to work on that. But other than that, thank you all very much. I want to wish you a very sincere good luck in your GMAT preparations. And perhaps I'll be seeing you again in another one of these lectures. Thank you again, everyone.